Welcome to my channel. We are looking at integral calculus, and in this video I'll give various examples that will enhance your skills in integration. So I'll begin with what we already know, that if you're given an integral of this form where n and a are constants, and you are asked to integrate it, generally this is how we give the solution. That it will be, we raise the power by 1, so this is x raised to n, so it will be n plus 1, then divided by the new power, then add the constant of integration, c. So that's what we just to do, and we'll look at various examples before we start doing other types of integration. So what we are saying is, when you are given the integral of x raised to n, a is any number, is any constant, n is also another constant. The integral of this, the solution to this would be, we just raise the power by 1, so it's ax n plus 1. So this is our new power, and we divide by this new power. What I've stated here is that this rule is only applicable when n is not equal to -1. So n should not be equal to -1. So what I'm saying is, we are not using this rule to do integration of this kind, where n is -1. So when n is -1, we'll come up with another rule for doing that. So let's just look at a few examples. And the first example here is, determine the following indefinite integral. And I hope you know the word indefinite means that these are integrals without limits. So we do not have, these integrals have no limits. For example, you're not saying that you're integrating from what point to what point. Now, so we want to look at these examples, and some of them are easy. Like the first one is very easy. As we said from our rule, is that we shall add 1 to the power and divide by the new power. So as seen, this a, the solution to this a, when you raise 1, when you raise the power by 1, so this is 3 by 1, and so the new power is 4, divided by that 4. What you have is 7 out of 4, x raised to 4, and then add a constant integration. So the first one is very easy. The second one is also very easy. Then we just add 1 to the power, so the solution becomes 3 out of 7, x raised to 7 plus 6. So when I add, this is 6. 6 plus 1 gives me 7. So that is why I get x raised to 7 and divided by that new power. The same to this one is also very easy. We're just adding 1 to the power. So let me show you my working, that I done this one earlier. So what I was getting as my workings are here. These are my workings. So for the first one, I said you just add 1 to the power, equals 4, and you divide by that 4. Then add a constant of integration. The second one, the same thing. Add 1 to the power, gets 7, and then divide by 7, and then add constant of integration. The third one is also that way. That's why I said add 1 to the power here, add 1 to 4. So this part becomes 7x raised to 4 over 4. And we also do this other one. Add 1 to the power, you get 3. So it will be 2 out of 9, x raised to 3, then divided by 3. And that is what you're seeing here as 2 over 27, x raised to 3, because 9 times 3 is 27. Then these are constants. There's 13, x raised to 0. 13 x raised to 0, because I know that x raised to 0 would be 1. So this is 13 times 1. So I just add 1 to this power and then divide by the new power. So this gives me 13x, and that's what I have here. Then plus c. So therefore, what you're saying is that the integral of a constant would be 17x plus c. Or for this one, the integral of a constant 13, the x is 13x plus c. So that's what I've used here, that when you're integrating a constant, just add the x. With respect to x, just add x to that. And let's look at part D of the examples. Now, so part D, I can see that this division is a division. So the first thing I'll do is to divide through first before I integrate. So what I have is 7 x raised to 5 divided by 5x squared, then plus 13 x raised to 2 divided by 5x squared, the x, the integral of this. So when I divide this, what I would get will be 7 out of 5 x raised to 3 plus 13 out of 5. These are constants, then the x. So this is what I have to integrate. This is what I have to integrate. And this is what you're seeing here, 7 out of 5 x raised to 3 plus 13 out of 5, then the x. Now to integrate this, you say you add 1 to the power. So this becomes 7 out of 5 x raised to 4, then divide by that 4. Then the other one is a constant, so it will be 13 out of 5 x, then plus c. But now 5 times 4 is what is giving me this 20. So I have 7 out of 20 x raised to 4 plus 13 out of 5 x plus c. That's how I did that. Now what about this one? Again, I have to do the same. I have to divide. So that is the same as 11 x raised to negative 3 dx. And so when you add 1 to the power, you'll have 11 x raised to negative 3 plus 1. And this gives you negative 2. So you divide by that negative 2 and then add a constant integration. And so that gives you 11x raised to negative 2 over negative 2 plus constant integration. And if you want to write this in as positive, then you write it as negative 11 out of 2x squared plus 2. You can even leave your answer at this point and it's still be correct. I wanted to express this as positive, this power, the power of x as positive. That is why I've taken it to the denominator. Now let's look at this other example. And we're just trying to simplify the questions that we have before we work them out. So what is this? What I'm seeing there is negative 11 out of 3, and this means fifth root, which can be written as theta 3 out of 5, raised to 3 out of 5, is theta. So once you simplify it, this way it becomes easy for you. So this will be the same as integral of negative 11 out of 3. We can take this theta raised to 3 out of 5 to the numerator. And when that happens, Since it's positive in the denominator, the numerator becomes negative. The numerator becomes negative theta. So we can now integrate by adding 1 to the power, and so this gives you negative 11 out of 3 theta, negative 3 out of 5 plus 1, and this is 2 out of 5. So we divide this by 2 out of 5. Divide by 2 out of 5. Then we add a constant of integration. So when that happens, this is the same as you multiply by the reciprocal of this. So when you do that, you get negative 55 out of 3 theta raised to 2 out of 5 plus constant of integration. Oh, those are 2 there, so this becomes 6. This becomes beta. And so that is what I got. That's what you get when you do that. And let's look at the other question, the following example. Now this one, it's easier to first of all expand this, and you can see that it's a square, so you just expand. And how do you expand? 2 times 2 gives us 4. 2 times theta gives us 2 theta. And then theta times 2 gives us 2 theta. This one has given us 4. And now theta times theta gives us theta square. And so when you add this two, you get 4 theta. And that's why I have 4 plus 4 theta plus theta squared theta. Now integrating this a constant with respect to theta, you get 4 theta plus, add 1 to this. There's a 1 here, so you add 1, that becomes 2, and then divide by 2. And so you'd have 2 theta square, and then when you add 1 to this 2, you get 3, and divide by 3, you get a third theta cubed, then plus constant integration. That is how we do that question. So it was just easy. First of all, expand this. But there's another way of doing that. So we have various ways of doing this. Let's look at the last example. And this one, again, we just have to write it, simplify it first. And this is 11 minus m over the square root of m. And the square root can be written as m raised to a half. M raised to a half. Now divide it through. When you divide it through here, what you will have will be 11 m raised to negative a half minus m raised to a half the m. But this is what you have. Now to integrate this, in fact it's here, it's what I wrote here. To integrate this, just add 1 to a half. 1 to negative a half. These are power. So negative a half plus 1, you get a half. So our new power is a half. So what we now have will be 11 m raised to a half, and divided by this a half, you have 22 m raised to a half. 22 m raised to a half. That's what I have. And this other one, again, raise this one by 1. So it's a half plus 1. That gives you 3 out of 2. So the new power is 3 out of 2. And now when you divide the whole thing by 3 out of 2, divided by 3 out of 2, it's the same as multiplying by 2 out of 3. That's what you have here. Then you add a constant of integration. So this is how we do integration of this kind, where you are given ax raised to n, and where a and n are constants. So if you're given integration of this kind, is what you do. And you've noticed that in some areas, you are forced, first of all, to simplify the fraction. For example, in this case, you are forced to simplify, first of all. In this case, you are forced to simplify before you perform the integration.